Let us look at the next section. This section contains 8 questions. Every question has 4 options, out of which one or more than one options may be correct. So let's start with question number 29. The shape of a molecule depends upon the orbitals which are involved in hybridization. Select the correct statements among the following. So the A statement, it says dz square is involved in sp3d hybridization if the shape is trigonal bipyramidal. Students, if we talk about the sp3d hybridization, there are 2 types of geometry. One is the trigonal bipyramidal geometry, whereas the other is the square pyramidal geometry. So students, in the trigonal bipyramidal geometry, the dz square orbital is used, whereas if we talk about the square pyramidal geometry, it is the dx square minus y square orbital which is used for hybridization, which is evident from the geometry or the structure. So the statement given in option A is correct. If we talk about the statement B now, during the reaction of a primary halide with a nucleophile, a trigonal bipyramidal geometry may be obtained at some stage. So this statement is also correct, students. It is the transition state which is formed during the SN2 reaction. In the transition state, the geometry is trigonal bipyramidal. So the statement B is also correct. If you talk about the C statement now, dx square minus y square is involved in sp3d hybridization if the shape is square pyramidal. So this is also correct, students. We'd already seen before. If you talk about the D statement now, dx square minus y square and dz square both are involved in sp3d hybridization. So this is also correct, students. In the sp3d2 hybridization, the given d orbitals are involved. So for this question, we have to select all of the answers as correct. Let us look at the next question. Question number 30. Consider the following reaction in which a diene undergoes a reaction under the Riemer-Tiemann reaction conditions. So we have a diene which is allowed to react with CHClBr2 in the presence of aqueous KOH. So if we talk about CHClBr2, in the presence of base, this will undergo alpha elimination to give us a carbene. So the OH is going to extract this H and the Br will leave. So this will lead to the formation of CClBr. So now this carbene will attack the double bond. So the carbene is going to form this structure upon reaction with the double bond, and now there will be shifting of bonds. So this bond will shift here, leading to the leaving of the Br group. So this will lead to the formation of a 6-membered ring with the double bond at this position and a double bond at this position as well, whereas the carbocation will be formed at this position from where the bond had shifted. Okay. Now this will undergo rearrangement to give us this structure, and this will undergo a loss of proton finally to give us an aromatic ring. So this is the final product which is formed at the end of this reaction sequence. So we have to comment on the incorrect statements among the given ones. So if you talk about the first statement, it says that the intermediate formed in the reaction is CBr2. This is incorrect, students. The intermediate formed is CClBr and not CBr2. So the first statement is incorrect. If you look at the second statement now, that the molecular formula of the product is C8H9Br, this is also incorrect, students. The product does not contain any Br. If you talk about the C statement now, which says that the product formed is aromatic, this is also correct, students. You can clearly see that a benzene ring is formed and the product is aromatic product. If you talk about the D statement now, product has 4 possible configurational isomers. This is also incorrect, students. Only a single product will be formed in this case. There is no possibility of formation of different configurational isomers. So for this question, we have to select the incorrect statements and we have to mark option A, option B and option D as the answer to question number 30. Question number 31. So in question number 31, we have been given 3 different bases which are named as pyrimidine, imidazole and purine. So the examiner is interested in the correct statements among the following. So option A, it says both nitrogen of pyrimidine are of same basic strength. So we have pyrimidine in the first structure. We can clearly see that both of these nitrogens are exactly identical. So they are going to have the same basic strength as their vicinity is identical. So the first statement is correct. If you talk about the second statement now, in imidazole, protonation takes place on N3. So if you look at the structure of imidazole given to us, we can clearly see that this lone pair of nitrogen is involved in aromaticity, whereas this lone pair is not involved in aromaticity. So the lone pair over nitrogen labeled as nitrogen 3 will be the most basic in this structure. So the B statement is also correct. If you talk about the third statement now, in purine, all nitrogen have same hybridization. So if you talk about the structure of purine which is given to us, we can clearly see that all of these nitrogen atoms have an sp2 hybridization. We might have a doubt about this one, but the lone pairs are involved in aromaticity. So this also is sp2 hybridized. So the C statement is also correct, students. And if we talk about the D statement now, purine, imidazole and pyrimidine are all aromatic. So we can clearly see that all of the structures are aromatic, as the first two structures have 6 pi electrons in complete conjugation, and the third structure is a bicyclic compound in which both the rings are aromatic. It has 10 pi electrons in complete conjugation. So the D statement is also correct. So students, for this question, we have to mark all of these options as the correct answer. Let us look at the next question. Question number 32. When a lone pair or a negative charge undergoes conjugation, it may alter the double bond between these two atoms. Consider the following species and identify those in which the bond order of every two atom lies between 1 and 1.5. So if we talk about the first structure which is given to us, we have carbonate ion. The bond order, we can clearly see that it will be given by 4 by 3. So this is equal to 1.33. If we talk about the second structure, ClO4 minus, we can draw the structure. So this is the structure of ClO4 minus, and if we talk about the bond order, it will be 7/4, which gives us a value of equal to 1.75. So the second compound has a bond order of 1.75 between two atoms. Now if we look at the third structure, which is the sulfite ion, SO3 2 minus. So we can have the structure as this. So we can see that the bond order is also equal to 4 by 3 again, which gives us a value of equal to 1.33. So the compound given in option C has a bond order of 1.33. Now if you look at the last option, which is Cl3 minus, so we can draw the structure as well. So this is the structure of ClO3 minus, and we can see that the bond order is given by 5/3, which will be equal to 1.67 approximately. So students, we have to select those compounds in which the bond order lies between 1 and 1.5. So we have to mark option A and option C as the correct answer to question number 32. Let us look at the next question. Question number 33. A sample of FeSO4 and FeC2O4 is dissolved in H2SO4 and is completely oxidized by KMnO4. After oxidation, the reaction mixture was reduced by zinc to the divalent state of metal, and further oxidation by KMnO4 required 5/3 equivalents. Choose the correct statement among the following. So if we try and figure out the system which is given to us, we have FeSO4 and we have FeC2O4, which is the ferrous oxalate. It is first converted into Fe3 plus ions and CO2 on reaction with KMnO4 in the acidic medium. Now this Fe3 plus is allowed to react with zinc. So the zinc converts the ferric ions into ferrous ions as given to us in the question. Now this Fe2 plus is further oxidized by KMnO4 in the acidic medium, where it is converted into Fe3 plus ions. Okay. So the final information about KMnO4 is given to us, that it required 5/3 equivalent. So we can clearly see that the equivalent of Fe2 plus present is also going to be equal to 5/3. So now if we have a conservation on the moles of Fe in the system, we're going to have that the sum of moles of FeSO4 and FeC2O4, the sum will also be equal to 5/3 moles, as all of the Fe present finally is coming from a mixture of these two compounds. So students, if you look at the A option now, the sum of total number of moles of FeSO4 and FeC2O4 is 5/3. This statement is correct, students. If you look at the second statement, if the number of moles of FeSO4 in the given mixture is 4/3, then the number of moles of acidified KMnO4 required to oxidize it completely is 4/15 moles. Now the examiner seems to be interested in the individual oxidation of the atoms. So he talks about FeSO4. FeSO4 is going to have an N factor equal to 1. only the ferrous ions will get oxidized. So 1 into 4 by 3, which is the number of moles, should be equal to the number of moles of KMnO4 into its n factor, which is equal to 5. So we can see that the number of moles of KMnO4 is going to be equal to 4 upon 15. So the second statement is also correct, students. If you look at the third statement now, in the third statement, the examiner says that if the number of moles of FeC2O4 is 1 upon 3, then the number of moles of acidified KMnO4 required to oxidize it completely is 0.2 moles. So if you talk about FeC2O4, the FeC2O4 is going to have an N factor equal to 3 because the ferrous ions will get converted into ferric, whereas the oxalate ions will get converted into CO2. So a total of 3 moles of electrons are lost by 1 mole of the compound. So we can have the moles 1 by 3 into the N factor, which is equal to 3. This should be equal to the gram equivalents of KMnO4. So the number of moles we have to find out, and the N factor is equal to 5. So we can clearly see that the number of moles of KMnO4 comes out to be equal to 1 by 5, which is equal to 0.2. So we can clearly see that the third statement is also correct, students. And if we talk about the D statement now, which says that the sum of number of moles of FeSO4 and FeC2O4 is 3 by 5, this is incorrect, students. We had seen that the sum came out to be equal to 5 by 3 as given in the A option. So students, for this question, we have to select the correct statements, and the correct answers for this question are option A, option B, and option C. Let us look at the next question now. Question number 34. The examiner seems to be interested in the resolvable amines among the following. If you talk about the A option, students, the compound given in option A is not chiral. It is not optically active. So the question of resolution of amines does not arise in this case. If you talk about the second statement now, so in the second statement, the nitrogen is a chiral center and it will not undergo flipping. So amines have a problem in resolution as they undergo amine inversion or the flipping of the bonds with the lone pair. So this compound cannot undergo the bond flippings and this will be resolvable. If you look at the C statement now, in this case also the nitrogen is a chiral center, and in this case as well the nitrogen cannot undergo amine inversion. So this will also be resolvable. And if you talk about the structure given in option D now, we have a carbon as a chiral center. So this will also be resolvable. So students, in this case we have to select the option B, option C, and option D as the correct answer. Let us look at the next question. Question number 35. K2MnO4 is unstable in pure water and the green color of the solution changes to purple after some time. This change is accompanied by. So students, we know that K2MnO4 is unstable in aqueous medium and it disproportionates into MnO2 and KMnO4. So if we try and write the balance reactions, we have MnO4 2 minus converting into MnO2 in the reduction half. So we can balance this using 2H2O, using 4H plus, and we'll have 2 electrons. So this is the balance reaction for the reduction half. If we talk about the oxidation half, we have MnO4 2 minus converting into MnO4 minus, and we can have a balancing using a single electron in this case. So students, if we talk about the options which are given to us, the A option, it says there is disproportionation of K2MnO4. This is correct, students. We can clearly see that Mn goes from a state of plus 6 to plus 4 and plus 7. If you look at the second statement now, it says that there is increase in pH of solution. You can clearly see that H plus ions are appearing on the left hand side, which means that H plus ions are getting consumed, which means that there will be an increase in the pH of the solution. If you look at the C statement now, precipitation of MnO2, we know that MnO2 is insoluble in water. So this is also correct, students. And if you talk about the D statement now, formation of KMnO4 in solution, this is also correct, students. The purple color present in the solution is due to the formation of KMnO4. So students, for this question, we have to select the correct option as all of these. Let us look at the next question. Question number 36. Two blocks of copper having the same mass M and specific heat capacity S are kept in contact and have different temperatures in a closed isolated box. It is given to us that temperature of the first block is greater than the temperature of the second block, and the examiner seems to be interested in the change in entropy as well as the final temperature. So if we talk about the final temperature, we can clearly see that these two blocks are exactly identical and they're going to have an exact same temperature, which will be the average of these two temperatures. So the final temperature is going to be T1 plus T2 by 2, which can also be equated by heat loss equal to heat gain. Okay. So the final temperature of the system comes out to be equal to T1 plus T2 by 2. And now if we talk about the entropy, we know that the delta S is given by integral of dq by t. So the value of dq can be written as ms dt, and it has to be divided by t and integrated. So the limits have to be put as t initial to t final. So this will give us a value of ms ln of t final by t initial. Now this formula was derived for a single block. We can put the value of tf and ti for two different blocks, and we have to add those values. So for the first block, the initial temperature is T1, whereas the final temperature is T1 plus T2 by 2. If you talk about the second block now, for the second block, we have the initial temperature as T2, whereas the final temperature is the same, which is T1 plus T2 by 2. So if we try and simplify this expression, we have ms ln of T1 plus T2 whole square upon 4 T1 T2. Okay. Let us look at the options which are given to us now. First option, it says that the delta S of the surrounding is 0. It is given to us in the question that the box in which they are kept is closed and isolated, which means that there is no heat which is lost by the system. So since the Q value is equal to 0, it means that the change in entropy of the surrounding will also be equal to 0. So the A option is correct. If you look at the second statement, final temperature of the system is T1 plus T2 by 2, we can clearly see that this is correct, students. If you talk about the C statement now, which says that the delta S of the system is ms ln T1 plus T2 upon 4 T1 T2, this is incorrect, students. There has to be a square of the temperatures at the numerator. So C option is incorrect. And if you look at the D option now, it says that the delta S of the system is equal to 0. This is also incorrect, students. It does not have a 0 value. So students, for this question, we have to select the correct options and we have to mark the answers as option A and option B.